molecular polarity and intermolecular forces. In a polar molecule, it's when one end is more positive and the other end is more negative. So this here kind of looks like a T, like a cross, so this should be the positive end, easy to remember. This here would be the negative end. H0 is a principle you should be familiar with. So H with an N, H with an O, or H with an F tends to be a polar molecule. So all of these here are examples for reference. If we look at these two different types of molecules here, both look symmetrical. The only difference is this has an H and this has an F. These elements, if you look at the electronegativity value of carbon, it's 2.55. If you look at hydrogen, it will be 2.18. I will show you where to get these values at the end of this video. The magnitude will be the difference between this 2.55 and the 2.18. Whatever the magnitude is, if it falls between 0 to 0.4, it's going to be deemed as nonpolar. If it's between this, it's going to be polar. And if it's going to be greater than 1.7, it's going to be ionic. But it's not that clear cut because we have other stuff to look at. Whatever magnitude that falls under and this one, because they're the same and they're in opposite directions, they're going to cancel out. So they would cancel out in that direction, but this one would also cancel out from left to right and right to left. So because they cancel out, this here would be checked off. All right, so they need to be symmetrical, they need to cancel out. However, also there needs to be no lone pairs as well. So there's no lone pairs around the central atom, so that's going to be checked off as well. So there's three things to look for: this, and this. If they are all met as a checklist, we can deem this question as true. So is this nonpolar? Yes. So we would deem this as nonpolar. However, this one here have the same magnitude in the opposite direction, but left to right, this is also going to go left to right as well because fluorine has a higher electronegativity value than carbon. So this here would not be nonpolar because they do not cancel out. In a nonpolar molecule, it doesn't have the charges present at the ends due to the reason that the electrons are finely distributed. So they're technically shared equally. So diatomic molecules are nonpolar, same thing with the noble gases. If we look at the electronegativity values of oxygen, it's greater than carbon, so it's going to be the same for this one as well. And they're in opposite directions, so they're the same magnitude, right? And there is no lone pair in the middle, so this would be a nonpolar. However, this one here has a higher electronegativity towards the oxygen side and also towards the sulfur side. Again, they have opposite directions, but they're not of the same magnitude. So this would not suffice. So this would be a polar molecule. All of these checklists need to be met in order for it to be deemed a nonpolar molecule. Here, this here, this here, these are the electronegativities.